Alright, in this video we are going to graph the solutions to the systems of linear inequalities. Remember, inequality has the greater than, less than symbols in there. So we kind of have to watch these guys because our lines could be dotted or dashed. The first thing these are just like solving for linear equations, systems of equations. I have two of them. And these are just inequalities. Where the other one's equations, this is inequalities. Remember, we want to get it in the y equals mxb form. So otherwise, we want to solve. Oh, sorry. We want to solve for y. We want to get y by itself. All right. So I'm going to take the first one, and we're going to put the first one here, and we're going to go ahead and solve for y. So I have to look at what's being done to y. It's being added by x, so I'm going to subtract x to both sides. And so then I bring down my y. This becomes a zero pair. It means it cancels out. So y is less than or equal to negative x plus 4. Alright, and I'm going to go ahead and graph this little guy so that way you can see what it looks like. And I'm going to do it in black. Alright, so my x-intercept is 4. Remember, the x-intercept's the guy in the back. The slope is the number in front of x, and since you see a negative in there, it's got to be a negative 1. So I'm going to go to 4. 1, 2, 3, 4. So there's 4 right there. Right, and the slope is a negative 1. Slope is negative 1, so that means it's negative 1 over 1. That means if I'm looking at rise over run, I'll go down and to the right. So I'm going to go down to the right, down to the right, down to the right, down to the right. And I'm going to go ahead and connect these dots, if I can do this. Okay, now I kind of rushed and didn't pay attention to what I was doing here. And if you look, I didn't copy question number 1 right. What did I screw up? Well, if you notice, the original one has no bar, and I put a bar on this one. It's just a habit. So I'm going to go ahead and fix this. And so that means I need to fix this. Alright, so it really is just less than, not equal to. So if that happens, what kind of line do I have? Well, I should have a line with just dots. So I'm going to go ahead and fix this. I'm hoping I can make this look somewhat good. Alright, so there's kind of a dotted line. Now, I need to test that line. And so what I mean by test, whenever you have an equality, is you want to pick, I always pick the origin 0, because it's on one side of the line or the other. And so I'm going to put 0, 0, 0 in for x and 0 in for y, and see if the statement's true. So 0 is less than minus 0 plus 4. So 0 is less than 4. Is that statement true? Is 0 less than 4? Why, yes it is. And so that means I shade the true side. And since 0, 0, this little area right here, is on this side and it's 0, 0, we shade this side here. Alright, so that one's good. Now I want to, and I'm going to erase this so we can do the next one. I'm going to try the next one. Alright, so my next problem, and I'll go ahead and erase this since we already know, since we are recording it. And I'll do this one in blue. So negative x plus 2y is greater or equal to 2. So remember, I want to get y by itself, so I'm going to add x to both sides. The reason why is because there's a minus in front of it. This becomes a zero pair. So now I bring down my 2y is greater or equal to, and I'm just going to say x plus 2. There's a plus in front of that, we just don't see it. Y is being divided by 2. So when y is being divided by 2, I have to multiply by 2, I got to divide by 2. So everything gets divided by 2. Now make sure you remember this little rule here. that when we're dividing by a negative number or multiplying by a negative number away from the variable, we flip the inequality. We're not doing that here. It's still positive, so we're okay. All right, so my number, y is greater than or equal to 1 over 2x. Remember, there's a 1 here. We're making it look like a fraction. And then plus 1. All right, so here we go. I'm going to go to 1, the y-intercept at 1. It's right here. And I got to go up 1 over 2, up 1 over 2, up 1 over 2. Or I could go down 1 to the... Wait a minute, did I mess up? It's positive? It is positive. Up 1 over 2. That's right. I can go down 1, left 2, down 1, left 2, and now I can draw my line like this. Now, before I draw it, notice my bar has an equal to sign, so that means it's a solid line. Now I'm going to test it. I'm going to use the same 0, 0 because 0, 0 is not touching it. It's right here, so I can. It's below the blue line, so I'm going to test 0, 0. So 0 is greater or equal to 1/2 times 0 plus 1. Is 0 greater or equal to 1? And the answer to that is no. So that means we're shading above that. See where 0, 0 is right here on the bottom part, so we're shading the top part. Now, our solution is where the two colors combine. So if you notice, that's this little area here. I'm going to go ahead and erase everything else so you can see it. But when I do, this is where my two colors combine. Alright, and I'm going to finish erasing this so you can kind of see it. I want it to be a clear picture for you. Alright, so right there is the two, that's where the two equations meet. What this section here means is that all points inside here, we can pick any point in here and it will make both statements true. So like if I pick that point there or that point there or that point, it doesn't matter what point I take, it will make it. Now, what if I picked a point on the dotted line? Would it work? No, it won't, because the dotted line means you cannot include numbers on that line. Now the solid line, yes, but the dotted line, no. So this would be our graph for this.